This demo is really for standing waves on a string. And you can see the vibrating string. This has a length of about 78 centimeters and a mass of 50 grams. Okay, and this vibrating, we adjust the vibration until we get loops. And these loops represent really the transverse vibration along this string due to the vibration will come from the vibrator and go along the string and will reflect back on the other fixed part. And then these two waves are transverse waves, the going on and the coming back, which is inversed. They will combine together the standing waves. And you can see here there are nodes where there is no vibration and the antinodes, which is maximum vibration. These two together, the length of the two loops together represent the wavelength of this oscillating rope. The frequency of the oscillating rope really depends also on the material we use and in the length. Here we fixed the length of the rope and we fixed the tension force from the attached mass. So we have this pattern. The frequency of the vibrating here, we have it at 14.4 hertz. This results in a pattern of two loops for that fixed length. And this is we have different patterns could be resulted here. This is really not the first frequency can be done. There is F1, which is half of this. We have different patterns. Those patterns, they have really common things that they are multiple integers of the basic frequency F1 for considering a one loop pattern here. So for example, if F1 is 10 hertz, we will find that F2 is 20 hertz with two loops. Okay, and F3 with three loops with F is 30 hertz. So we have here 14.4, that is for two F1. It means our F1 for this case is about 7.6 hertz. Okay, and this is the standing waves, and we call it sometimes transverse standing waves. Okay, and this is really used in a lot of equipment in physics, like the guitar and other things. Thank you. Okay, now I will adjust the case for three loops, and I'm trying to adjust that to get the standing waves with clear loops. Here you go. Little maybe more adjustment. You can see now the three loops very clear. I can see the anti-node where there's maximum vibration, the node which has no vibration at all. Okay? And we can calculate the frequency of this if we'll find it F3, F1. Okay? Now I can do that also for four loops, which here I will get the four loops. Slowly I'm adjusting the frequency to get the four loops. Here 28.7, 28. I'll add it little, 28.8, 28.9, I think the best. Yeah, could be between 28.9 or 29. So now we can see the four loops, and those represent two wavelengths. Okay? And this is the way we can consider the standing waves for different patterns. I hope you enjoy it.